So for today, we are actually moving back into chapter 4. We kind of took a little time out to do all the square root stuff. The reason we did that is because of this section right here, okay? So today we're going to look at finding or solving equations by finding square roots. We've done factoring to solve. We're going to do square root method today, and then we're going to do completing the square the rest of the week. Okay, that's your third method. If you look at the yellow paper that I gave you guys, that is how we're going to, I did it on yellow, hopefully kind of big. We're going to kind of keep filling this in as we learn the different methods for solving. But I want you guys to have this with you every day. We're going to kind of try to break things down for you step by step. So I have it up here. It's on your notes. Don't worry about writing it on your notes. I want you to write it on the big yellow page. Okay, that way you have it in front of you. So to solve a quadratic equation, the rest of this chapter, it's all about 4 methods. Your test over this, we're still a ways out from the test. This chapter is huge. But it's going to focus on the 4 ways to solve. Now your Angry Birds project, that was still chapter 4. Yeah, that was sections 4.1 to 4.3. So that's why the Angry Birds, did I not pass it back in here yet? Oh, sorry. I passed my other class back. Yeah, I'll pass them back to you. Sorry, my bad. It's in the grade book. But the rest of this chapter, that's why we did the Angry Bird project. It's over that stuff. Your chapter test will focus on the 4 methods for solving. Angry Bird stuff will not be on your chapter test. Angry Birds will be on the exam, but not the test. Got that? Okay. So the first part that we focused on was factoring. Do you remember kind of what you had to do when you solved by factoring? What was the first thing you did with the equation? Before that, what do you have to do with the equation? Standard form. There it is. So you wanted it ax squared plus bx plus c equals 0, right? We had to set those equal to 0. That was the first thing you did. Then you looked for a GCF. A lot of you don't like that stuff and forget it. So look for the GCF. Then you want to factor, right? That's where you factor in 2 sets of parentheses. And then set each factor equal to 0 and solve. All right, that was the factoring. I might have to throw a couple random factoring problems at you once in a while just to make sure you don't forget how to do that. By the time it comes for the test, I want you to be like, oh, we've done everything else. I don't remember how to factor anymore. So I might randomly want to throw some of those at you. Oh, absolutely. Absolutely. That's what you just asked. Yeah. Test and the, oh, yeah. Yeah, absolutely. No. All right, so this is the method we've already done. Today we're going to learn the square root method. Okay? It's different. Like factoring, you wanted to set it equal to 0. Square root method, you do not want to set it equal to 0. You want to isolate the x squared term. So you want to get the x squared totally by itself. So you might want to put in parentheses, divide by a if necessary. A lot of students forget that step there. All right, so get the x squared term by itself, divide by the a if there is one. And then you're going to take the square root of both sides. Take the square root of both sides. And then you'll want to do a factor tree if possible. Factor tree, this is all the stuff we've just been working on. Right, and simplify. Okay, so that's the new part for today, and that's what we're going to focus on, just how to do those. Back up to the top, though, right next to square roots, I want you to put a plus-minus sign on both sides of this, because most students will forget this one little step. And I'll explain that to you as today goes on. Okay, circle those, highlight those, star those. Most people will forget them. Okay, so keep this yellow page with you as tomorrow we'll look at completing the square. We'll work the rest of the week on completing the square, and then we'll look at quadratic formula next week. No, we haven't done that yet. Quadratic formula. A lot of students may have seen it before, though. The negative b plus or minus square root b squared minus 2a, b squared minus 4ac all over 2a. Some people may have seen that equation before. Never heard of it? A little of both. Just in Algebra 1, I always taught factoring, solve by factoring. But I never did the other methods in Algebra 1. So we got a little bit of both. All right, so solving by finding square roots. You can only solve a quadratic equation by finding square roots if there is no blank term in the equation. One of the terms has to be missing. Any guess which one must be missing? Well, the first step is to get the x squared by itself. So we definitely have to have that term. That's the b term is one that needs to be missing. Yeah, the bx term is missing. So you might want to look on your yellow page. You may want to make a note to yourself up here underneath square roots. So must be missing bx. So if it has a bx term, this method will not work. Now the question always is, why do we have 4 different methods? Like, why can't we just pick one and go with it? Factoring, does everything factor? No, not everything factors. But if stuff does factor, honestly, factoring is my go-to. If it will factor, I'll factor it because I can do that faster than any other method. If there's no bx term, square root method's a great one to use. Bless you. Completing a square, which I'll teach you guys tomorrow and the rest of the week. I'll be honest, that's usually never my option. State of Ohio says you have to learn it, so I'll teach you how to do it. After the test, if you never do it again, that's totally fine with me. I'll be honest with you. And then quadratic formula, that one's used a lot. Okay, so here we go. So, for example, which equations are missing the bx term? Let's make sure we can identify that before anything else. So how about this first one here? Is this one missing the bx term? Yes, that one's missing the bx. This one? No, it's right there. Third one? No, right there. This one? Yeah. So the first one and the last one, we could actually solve those using the method I'm going to teach you today. The middle two, they have a bx term. This method will not work. Okay? So, number 1, solve the equation by finding square roots. Now, before we do that method, because that's the new thing, this one will actually factor. I want you to see what happens. Oh, I'm sorry. To solve by finding square roots, isolate the x squared. Then take the square root of both sides. Yeah, we talked about that in our yellow page. All right, so number 1, though, we're going to solve by square root method, but I want to solve it by factoring first. Okay, so let's do it by factoring over here, because we know how to factor. Hopefully. If you don't, we're in big trouble. How does this factor? They're your squares. Right? If your last one's negative, what are your signs? Plus, minus. Square root of x squared? Just x. And square root of 25? Okay, so we would have factored, and then you would set each one equal to 0, right? Good. All right, so set each one equal to 0 and solve. So x equals, yes, you are. And x equals 5. I only do it because I know there's probably a couple students in here that probably need to see that. Yeah, as the chapter progresses, I'll stop. All right, so x equals 5 and negative 5. Great, right? We've done that before. So now let's solve this using the square root method. Well, our steps are to get the x squared by itself. How do I do that? Add 25. So x squared equals 25. Right, I just added the 25 to the other side. And then what do we write on our yellow page? I said divide by a if necessary. Do you have an a value to divide by? No, there's no number here. Take the square root of both sides. What's the square root of x squared? Good, it's just x. That cancels each other out. And then the square root of 25? Why did I get 5 and negative 5 on one and only 5 on the other? Should get the same answer. Why didn't I? what does it mean to take the square root of something? Or what's it mean to square something, right? Those are opposites. Multiply it by itself, right, Trey? So 5 times 5 equals 25. That's why the square root is 5, right? But what's negative 5 times negative 5? It's 25. So the square root of 25 is actually plus or minus 5, right? 5 or negative 5. So that is why on your yellow page, up here at the top, we did this. Oh yeah, I tried to throw that at you a little head time. So anytime you are taking the square root of something, so you are introducing that radical into an equation, your answers are plus minus every single time. Okay? That is where most students will lose a point. Because if I don't put the plus minus and I just write 5, how many answers did I list? One answer. How many answers are there? There's 2. So you will lose an entire point if you forget the plus minus, because you've lost an entire answer. Justin. As long as it's by itself, that's fine. But if I would move the x squared in this case, I've made it negative. Then I'd have to divide by negative 1 to get rid of that. But yeah, you can move anything you want, either side. Doesn't matter. All right, so number 2, x squared minus 12 equals 0. So we're going to use the square root method. Notice I'm missing the b term, right? There's no just plain x. So that your steps are to get x squared by itself. So what do? Add 12. So x squared equals a positive 12. And then take the square root of both sides. Yeah, the square root of x squared is x. Square root of 12 is not pretty. So everything we just worked on the last couple days, that's why we talked about it. Factor tree on the 12. It's 2 and 6. 2 and 3. So what do we get? 2 radical 3, right? Pair of 2's, single 3. And don't forget the plus minus. If you take the square root, you have to do plus minus. Yeah, is it that terrible? No, it's really not that bad. It does have a negative x squared. I can do that. Absolutely, I can do that, Noah. So on this one, Noah wants to move the x squared over here to make it positive. And you want to subtract the 6 over here? What's 33 minus 6? 27. Some of you, I know, just really hate to see the x squared on the other side. Doesn't bother me in the slightest, but I know some of you have a real problem with that. Okay. All right, your x squared's by itself. Okay, so let's take the square root of both sides. Square root of x squared. Square root of 27. Is it pretty? No. So what do we have to do? Factor tree. 3 and 9. 3 and 3. So what do we get? How many answers did you just give me? Plus minus. Now we've talked about, right, if there's an x squared, you know how many answers you should have, right? You should have 2 answers. If it's x cubed, how many answers will you have? If you have x to the 4th? 4. Chapter 5 is all about x cubed, x to the 4th, x to the 5th, x to the 6th, where you get more answers. It's not as scary as it sounds. It's really not. The graphing calculator is your best friend in chapter 5. There's totally different numbers. Wait till chapter 5. It's not as scary as it sounds. All right, what about number 4? All right, guys, number 4. What do you want to do with that one? Subtract the 9. So 2x squared equals 4. I have a lot of students who will try to take the square root here. Is x squared by itself? You got to divide by the 2 first. Yeah, you have to totally get the x squared by itself. So x squared equals 2. Right, now you see it's x squared. X squared's by itself. Now we can take the square root. So we get x equals, square root of 2 is, it's just radical 2, right? If I do a factor tree, I can't really do much with that. So it's plus or minus radical 2. I like that. If I don't have to do any extra work, it's kind of nice. Just don't forget that plus minus. What about number 5? You want to add the 5x squared? I like the way you guys think. That's what I would have done. And what do you want to do with the negative 9? Add it to the other side, and it gives me 12. What fraction? I don't see a fraction. Yeah, I do. Divide by 5. Right? Got to get that x squared totally by itself. You cannot take the square root of it otherwise. So I get 12 over 5. Right? That doesn't divide nicely. Now, what's your next step? Is x by itself? No, it's not. I have x squared. I have to take the square root. Please, 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 when you take the square root of fractions, remember our first step yesterday was to split the fraction into 2, right? Problem on top, problem on bottom. So fractions, you write the radical on the top, write the radical on the bottom. Please, please, please write it on top and bottom, okay? All right, so we get x equals square root of 12. Is it pretty? No. Factor tree? 2 and 6. 2 and 3. We could. So what do we get on the top? Get 2 radical 3. Radical 5? Radical 5, right? There's no pairs in that. You're right. What did we learn yesterday? You can't leave a radical on the bottom. So we have to multiply top and bottom by radical 5 because we can't leave that. Right? Good. 2 radical 15 over 5. And don't forget plus minus. Do you see why I took a little time out before I taught you this section? Yeah, all that radical stuff comes up big time in this section. I'm ready for the homework. Why don't you guys try this one on your own? All right, let's go ahead and go through it. You're either done or you need help, so we'll go over it together. So first thing you want to do, subtract the 7. So 3x squared equals 16. Divide by 3. Look like most of you at least did this much of it. So x squared equals 16 over 3. Right? We at least got to there. It looks like most of you did. Then, to get rid of the x squared, we take the square root. We do top and bottom separately. So x equals square root of 16, 4. Square root of 3. You're not the only one who did a factor tree. But you realize, though, if you don't have any singles, that it was perfect, right? Can I leave a radical on the bottom? No. So you have to multiply top and bottom by radical 3. So 4 times radical 3 is 4 radical 3. Radical 3 times radical 3 is just 3. And don't forget your plus minus. You got it. All right, questions on that so far? Okay. You have some story problems in there. I'm actually going to bypass them. And we're going to switch to the slightly more complicated quadratics with square root. No. So take a note up there. It says isolate the parentheses squared, and then take the square root of both sides. So I'm still getting the squared part by itself. Instead of it just being an x, it's a whole group now. Do not distribute that squared. That is wrong on so many math levels. Don't ever do that. Because, Trey, what's it mean to square something? You would have to multiply it by itself. So x minus 3 squared would be x minus 3 times x minus 3, and you'd have to distribute all of that. And then what? So why would you do it? It's not easier, because what would happen if you multiply that? Do you end up with a b term? Yeah. If I have a b term, can I use this method? No, I can't use that method, which I haven't taught you yet. So what? No, because then you'd have to move the 49 over, and then it would not factor. All right, so take a look. X minus 3 squared equals 49. Is the squared part by itself? It is. So now it's just like before, really. So I'm going to take the square root of both sides. What's the square root of x minus 3 squared? It's x minus 3. Square root of 49? Just 7? Just 7? There it is. I'm going to get very picky. Plus or minus 7. Yeah. You might not have, but we did. We did. All right, and then to get x by itself, I got to add the 3. Now, please pay attention. I'm going to try to help you guys out a little bit. When we are adding the 3, please don't write it underneath here because students have a lot of issues when they do that. Okay? I'm going to move it over right after the equal sign. I will still add the 3, so it becomes positive 3 plus or minus 7. I'm not done yet. Trey? Uh-huh. Very nice. I should have 2 answers. So x equals 3 plus 7. X equals 3 minus 7. Right? The plus minus that's 2 numbers. Positive 7, negative 7. Should I leave it like that, or should I actually tell you the number? Yeah, actually tell me the number. So x equals 10, and x equals negative 4. Will I write this on my next problem I do for you? No. I'll just write x equals 10 and x equals negative 4. Okay, but I wanted you to see that plus minus is indicating that's 2 numbers. You have x plus 7, or 3 plus 7, and 3 minus 7. You have 2 answers there. Okay, so take a look at number 11. Is your squared part by itself? I have to divide by 2. Nice. So we get y minus 1 squared equals 25. Plus or minus 5. There it is. Yeah, your squared part's by itself. So now we can take the square root. Y minus 1. What's the square root of 25? Thank you. Don't forget the plus or minus. Good. So then I want to go ahead. I need to get y by itself. We're going to add this to the other side. So we get 1, positive 1, plus or minus 5. Very nice. 1 plus 5 is 6. 1 minus 5 is negative 4. If you would like to list them with a comma in between, please do. That's totally fine. If you want to write y equals 6, y equals negative 4, you can do that too. But I'm lazy. I don't want to write all that. How are we feeling so far? I'm ready for that. Are you? Let's actually do 12 first, because something else happens here. What do we want to do first? Good. We need to divide the 3. I got to get that squared part by itself. X plus 2 squared equals 10. So is your squared part by itself? Yeah. So what do I do next? Do the thing, all right? I take the square root of both sides. Square root of x plus 2 squared? X plus 2. What's the square root of 10? It's 3 point something. If I do a factor tree on this, it's just, there's no pairs. You should definitely try, but there's no pairs, so I can't really do anything with it. And then I still got to get x by itself, right? I would do what? I would subtract the 2. Radical 10. So really, have I done anything different yet from the last problem? Before, I always put these together and actually told you the two numbers. Can I add a number not in jail to a number in jail? No. So guess what? You're done here. If you have a radical on it, then you can't actually go any further. You could do that. All right, guys, Trey's question was, could I write it as x equals -2 plus radical 10 and x equals -2 minus radical 10? Yeah, so you have two answers, right? There's one answer, there's the other answer. Lazy mathematician says I can write these as plus minus. But I'm glad that you're recognizing there is a difference there. Okay. 13 freaks people out. Why? There's a fraction. How'd you get rid of the 3 over here? So how do you get rid of the 1/3 over here? You could multiply by 3, or I could divide by 1/3. Same idea. It's the same idea. Yeah, so x plus 5 squared equals, you're right, that is 21. Nah, I haven't taken the square root of it yet. All right, so don't freak out, there's a fraction. It's just a number. And then what would you do? Good. Square root of both sides. So x plus 5 equals, good. Plus or minus factor tree? No pairs. All right, just making sure. Making sure. Yeah, nice. You seem to subtract the 5 over there. So -5 plus or minus radical 21. It's kind of nice when the radical's still there, right? You don't actually have to go further. You like the cute little elephant? All right, that is it for today.